Hello everyone and welcome back to this calculus course. Today is going to be the day in which we are going to learn how to deal with trigonometric limits. The trigonometric functions that we are going to use in this course are the following: sine, cosine, tangent, cosecant, secant, and cotangent. Now, for getting the limit of a trigonometric function, the approach is pretty much the same as regular cases. For example, if I want to get the limit when x goes to pi of sine of x, I can plug the value of pi into the function by doing the naive substitution, of course, and I will get the value of 0. Or for example, if I want to get the limit when x goes to 0 of the function cosine of x, I can plug the value of x equals 0 into the function cosine of x, and I get the value of y. But of course, the most interesting part are those in which we get the indeterminate form 0 over 0. For example, if I consider the limit when x goes to 0 of sine of x divided by x, or the limit when x goes to 0 of tangent of ax divided by x for a value of a different than 0, or the limit when x goes to 0 of 1 minus cosine of x divided by x, in those cases, I get the determination 0 over 0. So we have a problem, Houston. We have to see what we can do for solving those limits. Now, for the moment, we are going to accept as true the following remarks. The limit when x goes to 0 of sine of x divided by x will be equal to 1. The limit when x goes to 0 of tangent of ax divided by x will be equal to a, where a is a number different than 0. And the limit when x goes to 0 of 1 minus cosine of x divided by x will be equal to 0. We will assume them true, and we will prove them true later on in the course when we get to the topic of derivatives. Let us consider the following limit. The limit when x goes to 0 of sine of 2x divided by sine of 3x. If I do the naive substitution, I get the indeterminate form 0 over 0. So we have to do some algebraic manipulation to the function so we can get to the right limit. But now, if I multiply and divide by 3x and 2x, and I rearrange conveniently, we know for a fact that every time we have the limit when x goes to 0 of sine of an argument divided by the same argument, that will be equal to 1. And we get the limit when x goes to 0 of a constant. Now, let us solve this other problem. The limit when x goes to 0 of 1 minus cosine of x divided by sine of x. If we multiply and divide by x, we get the limit when x goes to 0 of 1 minus cosine of x divided by x times the limit when x goes to 0 of x divided by sine of x. And we know that the first limit goes to 0 and the second limit goes to 1. And by the laws of limits, we know that we'll have to make the product of these two limits, which will be 0 times 1, which is simply 0. As a final example, if we have the limit when x goes to 0 of tangent of 2x minus sine of x divided by x, we can arrange this expression as the limit when x goes to 0 of tangent of 2x divided by x minus the limit when x goes to 0 of sine of x divided by x. And we know for a fact that these two limits are equal to 2 and minus 1. Therefore, the whole limit is equal to 1. I invite you to solve the following trigonometric limits by using those that we already know they're true. So well guys, see you next time.